Okay, welcome. We're going to talk topic 6 today, surface area of cylinders and cones. All right, we've talked about these three shapes before and this word polyhedron and how they are made up of just polygons. Their faces are made up of polygons. And so I'm going to take a second, pause the video, and see if you can name all these things and the bases for each of these polyhedron. All right, welcome back. This first one is a prism. Right in prism there. Okay, and the base. Okay, well, the base here, it's kind of difficult. All right, so the way we tell what the base is we are looking for the two sides that are parallel, and there's a lot of sides parallel here. I would just call that a rectangle. And then we call this a rectangular. So the name of the base, prism. That's how we name prisms. Okay, over in letter B, we have a pyramid meets at a vertex, or sorry, an apex, and so this is the polyhedron name is going to be a pyramid. All right, the base is clearly what it's going to sit on, right? It doesn't sit on the apex, it sits on its base, and it looks like from all the markings there that we have a square. All the sides are the same, so we have a square pyramid here. Okay. Now, if that was a different shape on the bottom, if it was a triangle, it'd be a triangular pyramid or a pentagonal pyramid or whatever might be there. C is a little bit tricky. It kind of looks like a pyramid, but if you look, they don't all meet at one, all the faces don't meet at one apex, right? There's two spots where they meet there. There's a couple spots there. So this is actually a prism. All right, and now the hard part is, what is the base here? Okay, remember, we're looking for the parallel faces. Okay, so this square here on the end doesn't have a parallel face to it. Okay, these two rectangles right here and right here, I can't draw, it's kind of blinded. They're not parallel. The two things that are parallel is that triangle right there and that triangle right there. So the base is actually a triangle, which makes this a triangular prism. Okay, so that's the confusing part, but we're looking for which two faces are parallel when we're talking about prisms. Okay, so these are all polyhedron because all their faces are made up of polygons. Down here, we have three more figures that are not polyhedrons, so we can just go ahead and put a line through these. Okay, we'll talk about their bases, but if you look at all their faces, if you draw their nets, if we draw the net of what this looks like, it's actually a rectangle. If you wrap it around, it doesn't technically have a face, and two circles right there. This guy right here is going to be like a kind of a piece of pizza, okay, with a circle attached to it. A lot of times they'll put it down there on the end, and then I'm not even sure how you lay out that last one if you drew the net of it, but remember, this is not a polygon because it's wrapped around. I guess if you unwrap it, it is. So the base here is actually going to be a circle. This is called, I'm sure you've seen this before, cans of soup. This is a cylinder. I think of soup, and it's got two bases. Okay, so that's going to be important as we draw it out and come up with our surface area formulas. All right, not a polyhedron has a base that's a circle. So very similar to a cylinder, but if you notice, it meets at an apex. So it's kind of like a pyramid, and this guy over here is kind of like a prism. So they're almost like the ones right above them, but this is called a cone, snow cone, whatever you want to call it, and it has one base. Lastly, no bases really. So basketball just kind of sits on itself. This is called a sphere. Zero bases, I guess. Okay, and so we're going to take a look at these formulas down here below. All right, so I showed you the net of the very first one, the cylinder. If we draw that out, which had a little bit more space, but that's okay. Okay, let's draw out the net of that, and it's got two circles, one on either side there. So remember, surface area is just adding up all the faces. So laying it out like this is a whole lot nicer because you see the rectangle and the two circles. Okay, so area of a circle, we know, is pi times the radius squared. Down here, that's going to be pi times the radius squared. Okay. All right, so now we have to find the area of this rectangle. Where, well, it's got a height here, right? So if you look back up at this, you've got a certain height of this thing, and that is how tall it is. So we're going to call that h. And then it's got like a length to it, okay? But it's kind of special. And if I was here in person, I would have you roll up your paper into a cylinder. I'm rolling it up right now. You can't see it. All right. I would have you roll it up, and then I'd have you unroll it, and I'd have you look at that piece of paper and what part made that circle right here. Remember, this part right here, let me get another color. This right here, this part here really wraps around that circle, and this part right here wraps around that circle. Well, what do we call something that go the distance all the way around a circle? We call that 2 pi r, or circumference. Sorry, we call it circumference, and the formula is 2 pi r. So the length of this thing right here is actually the circumference. This is just the circumference of this circle, of that circle. Okay? So if we add all this stuff up together, we get, so surface area is equal to, okay, this is just like our previous, where we did prisms and pyramids. I'm just going to add up all our faces. We have 2 of these, so I'm just going to write it as 2 times pi r squared instead of pi r squared, adding it together twice. And then here, I guess I didn't write it in here, this is 2 pi r times h, right? Okay, because it's just base times height. It's a rectangle. So I'm going to add 2 pi r h. And that's really the formula. Just add it up. Don't memorize it. Just know that that's the circumference. That's how you can find it. You know your pi r squared. Add them together. All right, surface area of a cone is going to be a little more complicated. I'm just going to give you the formula here. It's pi times the radius times cursive L, where cursive L is equal to the slant height. Not the height of the cone, it's the slant height. So if I come up here and I label this drawing, it's this distance right here. This is the height right here. I am talking about this. This is the slant height. Don't know why I wrote that. You can't even read it. Okay, so you just plug and go. You may have to find the slant height. If you're given the height, you could use the radius here. That's the radius. You've got a right triangle, so you might have to find the slant height. But you can do that because you know a lot of stuff about a right triangle. All right, and a sphere, last but not least, surface area is going to be 4 pi r squared. Okay, get those down, and then we are going to work, I'm going to work the left side of these problems eventually. There we go. I'm going to work A, C, and E, and then you're going to do B, D, and F as your assignment or your practice problems. Okay, so first off, letter A, you have to identify it as a cylinder. Okay, and I like to lay it out. I like to draw it out so that I can see it. I like 2D as opposed to 3D. I'm going to draw this has a radius of 3. This has a height of 5, so I'm going to put my 5 right there. My other circle down here also has a radius of 3. Okay, then I'm going to start finding the surface here. I'm going to just start adding stuff together. So I know pi r squared. Okay, you can put it in 2 pi r squareds, but I'm going to write it out as all 3 of them. I put it down in the formula as 2 pi r squared, but I'm going to go pi times the radius squared. That's one circle, plus pi times the same radius squared. That's circle number 2. And then it's going to be, well, this is 2 times pi times r, which is 3, or I'll just cross that off. That's 6 pi. 2 times pi times 3, my radius. So that's 6 pi. So I'm going to add on base times height, or I'll call this maybe the base and that the height. And so this is going to be plus 30 pi. Okay, we plug all that in. I'm going to snag my calculator here. Apologies for the delay. Plug all that into your calculator all at once. You might be able to shortcut some of those things. You can do, like, I would just do 9 pi. Yep. Plus 9 pi. A lot of buttons here. Plus 30 pi. Plus 30 pi. Yep. and hit enter. And I'm getting, I'm sure if I do something wrong, I'll hear about it when I get back, 150.8, and that is, we're talking about inches, and we're talking about surface area, like how much could I paint on the outside of this thing, inches squared. Those will probably be the most complex, but let's take a look at a few more of them. The other two, you just have to use the formula. So the formula for a cone is pi RL. Wow, this one's pretty darn easy for you. Surface area is going to equal pi times the radius, which is 13, times the slant height. It's given right here. That's the slanted height, if you want to think it like that, times 30. Let's plug all that in. Move right along. Times 13 times 30. Enter. I'm getting 12, 25, and units squared. Okay, lastly, sphere, surface area equals 4 times pi times r squared, plug and chug, times pi times, what is that, a 7 squared. Let's see, let's go, that's going to be 49 times 4 times good old pi, there you are, and enter that. Surface area equals 615.8 centimeters squared. Okay, there you have it. There's some 3 examples. You are doing the next 3. You also, I think, have some Khan Academy on some of these problem types as well, but do B, D, and F as practice, and I'll have those answers posted to Google Classroom.